Okay, dear students, let us see what is there in this question. A battery of negligible internal resistance is connected to a lamp. A second identical lamp is added in series. What is the change in potential difference across the first lamp? And what is the change in the output power of the battery? Okay, so the question is like the lamp can be regarded as a resistance only. So this is the first case, and they are now connected with the battery like this. So this battery is V and the resistance is R. So obviously, what is the potential difference across the resistance R now? So it will be equal to the EMF of the battery. So in the first case, like case number one, the PD, that is the potential difference, will be equal to V. And now what is the case number two? Case number two is now that we have two identical set of lamp. So this is R and this is R and this is V. Obviously, in this second case, the potential, the total potential that is divided into two different resistances and they are shared equally. So this will become V by 2 and this will also become V by 2. And also in the case of series, I'm going to give you one formula like if this is V1 and this is V2. So the formula it goes like this. V1 is equal to R1 into V divided by R1 plus R2. And from here also you would be getting the same answer. Why I'm giving you this formula? Because this formula is important for us to remember and it might help you somewhere else in some other question. So now, obviously, as per this R is concerned, is this lamp is concerned, in the case number two, the potential difference is V by 2. So it decreases. So either A or B. Now, what is the output power of the battery? So in case number one, I'm just calling it P1. So the power output power of the battery will be V into I. So there are three formulas for the power, my dear students, VI, I square R and V square by R. Whenever we are concerned with the output power of a battery, we must use this formula. And whenever we are concerned with the power dissipated in some particular resistances, we use this. And this in some particular cases, which I'm not mentioning now. So in this question, we are now going to use VI. But later, we come to know that for I, we have to substitute V by R, so it will become like V square by R. Anyways, we have to substitute the value. Now we are going to P2. So P2, in this case, we are using now V into I, so the EMF does not change, but the current will change because there are two resistances now. So what is the current now? The current will be V divided by R equivalent, which is 2R. So it becomes V square by 2R. So eventually you can just compare these two things that in the case number one, there is more power that is delivered by the battery. Just watch my wording. I'm not saying the power consumed by the resistance. I'm saying power delivered by the battery, although both of them are same in the first case. But still, so the power delivered by the battery, it also decreases. So our answer comes out to be equal to A. So, ladies and gentlemen, this is Professor Varun, and you can subscribe to this YouTube channel. Please share this channel with all of your friends. All the best.